So we're going to start doing absolute values. And so just kind of refreshing what absolute value means. I'm just going to read right from the textbook. The concept of absolute value should be somewhat of a refresher, but we're going to graph the absolute value functions, and that's what I'm teaching, the new stuff. It says written as the absolute value of x. You guys do recall that the absolute value of x is remember that the straight up and down lines, whatever's trapped in between there, we would say those are called absolute value brackets. Okay, so whenever you see something written in straight up vertical lines, that's the absolute value. So just kind of reading along from the textbook, it says written as the absolute value of x, it represents the distance between x and 0 on a number line. As a distance, absolute value is always non-negative. Okay, and so they give us two examples. They say that -5 is on the number line, right? Because we're going in the negative direction or the negative side of 0. And then going to the right of 0 is kind of considered a positive side. So the number has a distance. In other words, to get from 0 to -5, I move 5 units, right? And to get from to +5 from 0, I move 5 units. One, I move in the positive direction. The other one, I move in the negative direction. So when we talk about absolute value, we're really talking about the distance between 2 points. Sometimes we move in the negative direction. Sometimes we move in the positive direction. And that's how we get the negative and positive numbers. So an absolute value function can be defined as a piecewise function that essentially focuses on two parts. It focuses on the positive values for x when x is greater than or equal to 0. And then it focuses on the negation of that. So when x is less than 0, which is a fancy math way of saying a negative number, we do a thing called negate a negative, which means that we're going to take the negative of the negative, which is positive. So if we do the math on that, and I'll show, I'll write a couple out, and then we'll graph this on a graphing calculator. I like to do these by hand a little bit because I think it helps. So if I want to evaluate f of this thing is not cooperating today. F of negative. Why is that not cooperating? F of. I just fired this bad boy up. Why? It's thinking. It's like thinking or something. -8. F of -8. It's a piecewise function. So what is my x value? Well, my x value is less than 0, right? So when it's less than 0, I'm going to multiply it by a negative number. In other words, I'm going to have negative x. Why does that keep doing that? Right? But instead of x, I'm really going to say -8. So wherever there's an x, I would plug in -8. That's going to be a problem. So what's the negative of -8? +8. And then I'm just going to use my mouse. I'm tired of this thing. So then f of -4, again, same scenario. It's a negative value for x, so I'm going to take the negative of whatever that number is. And so that would be +4. And then 0, actually, let me back up so you guys could see what I'm doing. 0 means that my x value is greater than or equal to 0. So now I just write it down as is. And the mouse isn't any better than the... Let me try one thing. I hate to do this while I'm recording, but... All right, maybe that'll fix it. All right, so this is 8. Oh, yeah, that's much better. Doesn't like that thing. All right, so now we got to plot the points. So I've got negative 8, 8, right? Right, if I plot the points, I go, this is like x comma y, x comma y, x comma y. So I've got 8, negative 4 comma positive 4, 0 comma 0. Maybe I'll do this in a different color, like green. So this is my first point. This is my second point. This is my third point. The next one is 4 comma 4. So I'm just taking these table of values and plotting them. So I've got negative 8 comma 8. Let me write it down so you can see it. Whatever I write down, you guys should write down. And 0 comma 0. So I'm just plotting this table of values as ordered pairs, as coordinate points on the plane. And then 8 comma 8. And so, oops. And so what happens is you get this V shape, right? That kind of goes like this. Now, you could do this on a graphing calculator. If you have a graphing calculator, fire that bad boy up. Hit clear, go to y equals. Let me move my face out of the way. Clear all of your y equals out. And then to get the absolute value function in your calculator, we're going to go to math. Okay. And if you scroll down, I got to remember where it is. It's on here somewhere. Is it numbers? Yeah. So if you scroll over one to the right where it's numbers, you could take the absolute value. So that is the function. Now, when you hit that, notice that I have the absolute value brackets. You guys see that? You guys should be practicing this on your calculator. Let's go. Grab a calculator, plug this in. I want you to be able to do this on your tests on the SAT and the PSAT and the NWEA. There's a lot of assessments. All right, so now we're going to plug in X. So what we just did is we did this stuff, right? Go ahead and hit zoom. Choose option number 6. Bam. Look what I got. That is the same thing that we just did. Go ahead and hit second table or second graph button. And as you can see, this is the interesting thing here. What they do is they just take the positive and negative X values. And so one misconception, and I'm going to copy and paste this over here on my notes. One misconception is that I'm going to make this kind of like that. Let me slide this over here. One misconception is you take the negative of everything. No. You only take the negative of the negatives. In other words, when I look at y1, when I look at all the y values, they're all positive or what we call non-negative because I have this 0. 0 is not positive nor negative. So the absolute value function, whatever is trapped in the absolute value function, is forced to be non-negative. So if I have a negative 3 in there, it becomes positive 3. If I have a positive 3, it just stays positive 3. Does that make sense? All right, so let's finish this example. So it says now examine the function f of x equals absolute value of x and complete the following statement. So f of x equals the absolute value of x is symmetric about what? If you look at the graph. Huh? The y-axis, very good. Yeah, it's symmetric about the y-axis. And is a what type of function? Do you know? So remember that an even function is symmetric about the y-axis. An even function is symmetric about the y-axis. So whenever we have something that's symmetric about the y-axis, it's an even function. Just know that. Okay? What's the domain of this bad boy? What do you guys think it is? Yeah, so the domain is the x values. How far do you think this goes? Yeah, so that's going to go to infinity, right? Let me write in black so you can see it better. So the lower boundary is negative infinity. How far does it go this way? To the right. Positive infinity. Okay. Now, the range refers to the y values. So what's the lower boundary for y? What's the absolute lowest y value you would expect to see based on the graph? 0. Are we including 0? Yeah. So what does that mean? What do I put here? Bracket. And what's the highest y value you would expect to see? Infinity. Well, it approaches infinity. Infinity is not a number, so we can't say it's a value. Right. Any questions on that? How do you guys feel about that? Thumbs up if it kind of makes sense. Thumbs down if it doesn't. Okay, that's all right. You could be here. We just keep going over it until everybody's here. All right, I'm gonna stop that.